Hello and welcome to another video. Today's topic is sequences and patterns. This is what I'm calling chapter number 7. It may be a different chapter in your book, but sequences and patterns is an important topic for O-level maths. My screen is on. I just fix my screen. Yeah, okay. We're back. So now it can come up in paper 2. It can come up in paper 1. It relies on your ability. It relies on your ability to sort of figure out patterns of numbers basically. Okay, the better you're at gauging what numbers, how the numbers are changing, the better you will be at sequences and patterns. And it's a very important skill for later on as well. Sequences and patterns come up in lots of university tests. When you're applying for jobs, they also come up there because it's a basic IQ thing that you need to know. Okay. So a sequence is a list of numbers or terms which vary according to some rule. Each term is related to the previous term or to its place in the sequence. Okay. The nth term is in a sequence provides the formula for working out every term in the sequence. For example, the nth term is 3n plus 1. Then the second term is going to be 3 into 2 plus 1. So you place the value n equals to 2 into the sequence to find out what the second term will be. We will talk more about this. There's a question later on coming up. We will explain what the nth term really stands for. Okay, so moving on. This is number sequence is a list of numbers for which there's a rule that explains how to find the next number. For example, for the sequence 1, 3, 5, 7, 9, the rule could be add to or write down the next number. Okay. For the sequence 5, 10, 15, 20, basically multiples of 5, there could be a rule write down the next multiple of 5. Okay. For the sequence 0 0.3, 0 0.6, 1.2, 2.4, the rule could be multiplied by 2. You can see that every subsequent term is being multiplied by 2 to get to the next term. Okay, the numbers in a sequence are called terms. A sequence begins with its first term. So the numbers in a sequence are called terms. So each of these were terms. You should need to know that. Whenever I say term, I mean a particular result of some calculation that was going on behind it. The second thing that I want you to know is that each one has a term number. So this is the first term, this is the second term, this is the third term, this is the fourth term. Okay, n is 1, n is 2, n is 3, n is 4. That's what we're going to talk about. The numbers in a sequence are called terms. The sequence begins with its first term, followed by its second term, and so on. In some sequences, the term-to-term rule for finding the next term may have to be investigated carefully. Okay, so we're going to see lots of different types of sequences in this lecture. It is sometimes useful to compare sequences with the simple sequences that we already know. So yeah, we'll talk about that. Not to worry right now. Okay, for each of the following sequences, write down the rule that explains how to find the next term, then find the next three terms in each sequence. Okay, so the first one looks simple. So these are multiples of 7. So multiply multiples of 7. Let's not write just multiples of 7. You can also write add 7 to the previous term. Okay, what are the next three terms then? Next three terms are uh, 42, 49, and 56. Okay, so 2, 5, 10, 17, 26. Okay, let's see what the next term should be, and then we'll decide what the that's adding 4, adding that's adding 5, adding 7, adding 9. Okay, 2. It's basically add the next odd number series, odd number from the difference series. Okay, so we're able to describe them as rules. Honestly, I don't know what the actual answer says, but I'm just telling you, you need to add 11, so you get 35, 37, sorry, 11, 37, then you need to add 13, so you get 50, and then you need to add 15, so you get 65. So those are the next three terms of the sequence. Okay, then we have C, so that's 1 over 3, 2 over 3, 3 over 5, 4 over 7, 5 over 11. So the numerator is just is a sequence of integers. Okay, let's see what's happening in the denominator. So that's 2, 3, 5, increase of 1, increase of 2. I think, no, that's not how it's working out. It's just prime numbers in the denominator. You need to be aware of that. Okay, that's one question. Let's look at what the next one says. This next one says square tiles and square colored tiles, or square white tiles and square colored tiles are used to make the pattern shown in the diagram. Pattern 1 has been removed from the diagram because it was drawn incorrectly. Okay. Copy and complete the table to show the number of white tiles, the number of colored tiles, and the total number of tiles and patterns 1 to 6. Okay, so number 3 is drawn for us, and number 3 has also been counted for us. For number 2, let's just count. Okay, so that's 1, 2, 3, 4. That's 4 white tiles, and 1, 2, 3, 4, 5, 6. 6 colored tiles, the total of 10. Similarly, pattern 4, so 1, 2, 3, 4. Okay, let me hit this line. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 white tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 26. Okay, do I see a pattern? Yes, I see a pattern. This is 4, 6, 8, 10, and 12. That's what the pattern should be. So this should be 2. And this pattern says that you have 6, 11, and 18. So I've added 5, then I've added 7, then I should add 9. That's 27. And then I should add 11. Okay. Then 11, 38. So that gives me a total of 50, 37. Okay. So I should have added 3 here. That should have been 3 for me to add 3 next. Okay. Should have been 5. Okay. Use the numbers in your table to draw pattern 1. Okay. Now this has got to be a little. Just find the number of tiles in pattern 10. So let's just do this. Okay. So I see that the number of tiles are 5, then 7 more, then 9 more, then 11 more, then 13 more. So there should be 15 more, so there should be 65. And then there should be 17 more. So there should be 82. And there should be 19 more. So that's 101. And then there should be 21 more. So that's 122. Okay. So slightly awkward question, but that's fine. So then we move on to what we call the nth term. Now, read this carefully. It says, for some numbers sequences, it is possible to find an expression that shows us how to work out any term using the position of the term in the sequence. If we use the letter n to represent the position of the term, so n is always the position of the term. N equals to 1 represents the first term, and n equals to 2 represents the second term, and so on. Consider the expression 7n minus 5. So what is the first term going to be? I plug in 1 into this expression. 7 times 1 minus 5 will give me 2. 7 times 2 minus 5 will give me 9, and so on. Okay, so when n is 1, then the term is 2, then n is 2, the term is 9, and so on. It says we say that the nth term of the sequence is given by the expression. So whenever you have the idea of the nth term, you're going to end up with a formula that you need to solve. Okay, I just figured this one out, so I'm just going to tell you. So what's going to happen is that you'll have 3 colored boxes like that. Okay, and then 1 empty box like that. So that is what the first one will look like. Okay, okay, moving on. Let's see what this one says. It says the term to term rule for a sequence is multiply the previous term by 3 and subtract 1. Okay, the first 3 terms in the sequence are 1, 2, and 5. Write down the next 2 terms in the sequence. So multiply with the previous term by 3 and subtract 1. So what does that give you? That gives you 14. Then you multiply the previous term by 3 and subtract 1. So that should give you 41. Okay, so the next 2 terms are 14 and 41. The nth term of a second sequence is given by the expression 4n minus 3. Find the number in this sequence that is closest to 150. So what I'm going to do is I'm going to say that this is equals to 150. Now, since this is a no calculator paper, I will have to do a bit of guesswork in terms of what number should be closest to 150. I could have also done some trial and error and gotten to the right answer, but this is a better way of doing it. So 4n equals to 150 divided by 4. Okay, so n equals to 150 divided by 4, so 2 times 2, 2 times 75. 2 times 37.5. Okay, so it's either the 37th term or the 38th term. Okay, let's find out what the 37th term is. Okay, what's 37 into 4? 4 times 7 is 28. 2, so 4 times 3 is 12, and 14. So that's 148 minus 3, that's 145. What about 38th term? For it is 32, 4 times 3 is 12, and 15, so that's 152. Oh, I missed out the 3 here. That was the real problem. Okay, I think I've solved this incorrectly. Let's solve this again. Okay, it says the nth term of second sequence is given by the expression 4n minus 3. Find the number in the sequence that is closest to 150. Okay, so what I should do is, in fact, I should just do trial and error on this and tell you which term is the closest. So let's say I think that it should be the 20th term. So that tells me that I'm really, really far away. Okay, so I think I should go on to the 40th term. Okay, so that's 160 minus 3. Okay, so I am how far apart? I am 157. I'm not as close to 150 as possible. So every subsequent term is just 4 more than the previous term. You see that 4 is being multiplied. You'll understand this idea in a bit. So the previous term should be 153, and the term before that should be 149. So what is the term? Find the number in the sequence that is closest to 150. So 149 is closest to 150. Okay. That's part B. Part C says the term of a different sequence is given by the expression n squared plus 1. Write down the first 4 terms of the sequence. So 1 squared plus 1 gives me 2. 2 squared plus 1 gives me 5. 3 squared plus 1 gives me 10. Okay, and 4 squared plus 1 gives me 17. And so I've done an expression in terms of n for the nth term of the following sequence. Okay, now you might not understand this right now, but it's connected to this. You see how these terms have moved? The first term is for the first term was 2, now it's moved to 0. The second term was 5, now it's moved to 3. So every term in this new sequence is 2 behind the term that it was supposed to be. So what's going to happen is um, I can just simply say that if this sequence was 2, 5, 10, and 17, and the sequence is 0, 3, 8, and 15, so what I've just done is subtracted 2 from all of these terms. So if this term had the expression n squared plus 1, I'm just going to subtract 2 from this and end up with n squared minus 1 for this new sequence. Okay, slightly tough question. So make sure that you understand this well. Don't rush through it. Otherwise, you will feel lost. That's it for this video. I will be back with another video in the next recording. Thank you for watching.